That's the difference between
Yep.
calculus and everything else before it. And in fact, what I have circled here, you probably reckon, nah, not quite. You're probably not quite there yet. That's the definition of first derivative. But
Yeah, we went over that today, actually,
okay,
briefly.
okay, cool.
We
So
just introduced it. Yeah.
you have stuff you can verbalize, or do you need to send me something?
I just emailed you something, actually.
Okay. So while I'm waiting for that, tell me what the limit of this is as x goes to 0.
Undefined.
Correct. And what if I
Negative.
had x over 1 as x goes to 0?
It would be 0.
Yeah. All right. Let's see what you got here. Where do you want to start? Looks like I got two different. Is the one on the left the first one, or?
I think so. It should be, actually. It's 11. The problems possibly on the quiz are 11 through 55.
Okay. So shall we start with 11?
Yes, that works.
All right, let me blow this up a little bit so we can both see it on my screen. Can you see that okay?
Yep, perfect.
Okay. What's 11?
So it would be negative 3 squared, which is 9. Then 9 minus 13 is 4, or negative 4.
Okay, how about 12?
12, so that would be negative 4 plus 10. So that would be 6 minus 2, which is 4.
Okay. Just keep going through them. These, incidentally, are always easy. The only ones that are ever tough are where you get 0 over 0. For example, 22. When you plug in 0 for h, you get 0 over 0. That's indeterminate. And those are the ones that are tough because they require a lot of more algebra.
Okay.
The ones that produce just a number, we can spend time going through them. Let me see if, in other words, 13 is a piece of cake, right?
Yes.
14 is either going to be 0 or some number, so it's a piece of cake. 15, what's 15?
So that would be 4 plus 5, which is 9. Then it would be 11 minus 2 cubed. So that would be 4, and then 4 squared, 8. So then that would be 11 minus 8, and that would be 3.
Okay, good. Let me see if I can find a tougher one here. I don't want to skip these necessarily, but we can always come back to them if we have time.
Okay.
Usually time is the problem. 16 is going to produce a number. 17 is going to produce a number. 18 is going to produce a number. So far we haven't found any tough ones. 19 is going to produce a number, but what do you get with 19?
So it'd be 5 minus, or plus 3 to the 4 divided by 3.
What is that? How do you do 8 to the 4/3 power?
Yeah, you also said I couldn't use a calculator, so I have to
Huh?
do this all myself.
Yeah, no, I know. I don't want you to use a calculator on this. Always
Okay.
start with the root. That means the third root. And then we're going to take whatever answer we get, and we're going to take it to the 4th power. So what's the third root of 8?
Okay, so 64 times 8.
What's the third root?
Oh, that'd be 2.
Correct. And then 2 to the 4th?
So that would be 4, 8, 16.
Notice how much easier. You can do these in either order. In other words, we could have done 8 to the 4th and then taken the cube root of that. But 8 to the 4th is a big number, and then we would have needed a calculator to do it. So it's always better to take the denominator, which is the root, first. Okay, let me look at another one. What's 20? Yeah, that's no problem.
So that'd be 16 minus 10. So that'd be 6, then square root of 6.
Yeah. All right, let's look at 22. That's the first one I see that there's any difficulty at all in it. Which is interesting that they would start you. The very first tough one they give you is a significantly tough one. We want the limit of this as h goes to 0. I'm going to blow it up so it covers the whole screen here. Notice that with direct substitution, I get the square root of 4, which is 2, minus 2 is 0, over 0. And whenever you get 0 over 0, you don't know what the answer is. It could be anything. It could be 0, it could be infinity, it could be undefined, it could be 17. Okay? So the only way to reduce these is by manipulating the fraction. And hopefully we can manipulate it enough so that it won't result in 0 over 0 again. Now, there's basically 3 techniques you use when you're manipulating these. And this is the hardest one that we're going to start with here. That's why I don't particularly care for this method. I prefer starting on easier ones. In fact, I'm going to make up the one that I think everybody should start on. Let's do this one here. Notice, oops, excuse me. What was I thinking? Hold on a second. Let's see, as I don't want x to go to 1, I guess I need an x minus 1 in the bottom. There we go. Notice that with direct substitution, you get 0 over 0, right?
Yes.
Factor the top, what do you get? Factoring is the typical first method that you would use to avoid, not to avoid, but to, as your first step to go further. How do you factor the top? You'll see what I mean.
X plus 1, x minus 1.
And now notice that the x minus 1s can be canceled. And now substitute. What do you get?
So that would be 1 plus 1, and that's 2.
Yeah. So this is the typical way that you would solve limit problems when you end up with 0 over 0. You would start by factoring, okay? And that's always the first method you should look for if you can do it. Now, in this particular problem, 22, that we're looking at here, can't factor that. In fact, it's got a very complicated numerator. We got the square root of a binomial, and then we're subtracting 2. The method you use here is to multiply by the conjugate, top and bottom. It's kind of like imaginary numbers. If you remember how you handle imaginary numbers, if you have an imaginary number in the denominator, you multiply top and bottom by the conjugate. Well, I'm going to do the same thing here. I'm going to multiply it. Here's the conjugate of the top, 5/8 plus 4 plus 2. Got to multiply the bottom by that because the only thing I'm really allowed to do is multiply this fraction by the number 1. And might not be obvious why this is what we do, but you'll see in a second. When you multiply the top, what are you left with? Think of it as the difference of perfect squares. What the left side is a minus b, and I'm going to multiply it by a plus b, right? And that's always going to give you a squared minus b squared. So let's use this principle in doing this multiplication.
Okay.
There's my a minus b, there's my a plus b.
Okay, so it would be 5h plus
a squared, which is what?
5h plus 4. Square root of 5h plus 4.
No, we're squaring that. In other words, if that is a, well, my first term is a squared. So you would write the first time, it's 5h plus 4. And then we don't have any middle term. Remember, when we have difference of perfect squares, is all we have is the a squared plus the b squared. Well, the b is 2 in this case, so and it's minus, excuse me. In other words, it's a squared minus b squared. So look what we have. We have the 4's cancel, and we end up with 5h, and now what do we have in the denominator? We have this h multiplied by this whole thing over here. Don't ever really try to multiply them together. It's fruitless to try to multiply them together because you'll see what's going to happen. Now I can cancel this h with that h. And what do I have? I have 5 over the square root of 5h plus 4 plus 2, taking the limit as h goes to 0. I'm not sure what it's going to be, but I know it's not going to be 0 over 0 because I already have a 5 in the numerator. So the limit looks like it's going to be 5 over 4. You see how I got it?
Yeah, because the 4 gets square rooted, then 2 plus 2 is 4.
Right, right. But the key is to notice that when you have that kind of a complicated thing, especially with a radical, if there's a radical in the numerator or the denominator, the first thing you really should think of is multiplying by the conjugate, because it releases an h, which can then be canceled with the h in the bottom, and it's a lot like the factoring that we did. Once you cancel that, then you're no longer looking at 0 over 0.
Okay.
Okay. Let's see. That's the third technique. There's a second one. We'll run into it, I'm sure. What are we supposed to do? 11 through what? 29?
Possibly, like, let's name this 55, but we don't have to do all of them, just skipping through.
Okay. We got half the time left. So you can see that everyone after 23 is going to be 0 over 0.
Yes.
All right. So we can just kind of assume that without doing the math. So let's look at 23. 23 is the more typical problem, which you're going to solve by factoring. As x goes to 5, it's 0 over 0. So manipulate that fraction.
So that would have to be x minus 5 over x plus 5 and x minus 5.
Now,
and x minus 5's cross out.
Now reset 2. And that leaves 1 in the top, incidentally, not 0. So
it'd be 110.
1 over x plus 5, which is 1 over 10. There's our answer.
Okay.
Okay. Let's do one more of those, and then we'll skip around and look for harder ones. And again, as x goes to minus 3, top and bottom both go to 0. So what am I going to do?
So then I'd have to factor. So it would be x plus 4. No.
Remember the
X plus 1.
and
X plus 3.
And those cancel, and I'm left with 1 over x plus 1. And now what's the limit?
We just substitute the negative 3 in, so it would be negative 2.
Negative 1/2.
Correct.
Okay. In other words, it's still 1 over the negative 2, negative 1/2. All right. Let me see if I can find some that are going to be tougher. 25 is just like 24. You're going to factor the top. It's going to cancel out with the x plus 5. And in fact, one of the secrets you can almost know here is that when you go to factor that quadratic, one of the factors will always be this on the other side of the fraction. In other words, on 26, I know one of the factors of the numerator is going to be x minus 2.
Okay.
Okay? 27. Let's do 27 because that involves factoring both. We got t squared plus t minus 2 all over t squared minus 1. And as t goes to 1, we get 0 over 0. So factor top and bottom.
So it'd be t plus, t plus 1 and t, no, let me think.
Make sure,
So
you're producing the middle term. That's always the secret with factoring.
Okay, so the middle term will be t.
Which is 1t.
Correct.
Okay. So what do I know my signs? My signs have to be opposite.
You have to have a positive 1 because I have to have a 1t.
Right. So if I put and the only factors of 2 are 2 and 1, right?
Yes.
Put the larger of those factors with the sign of the middle term. The 2 has to go there. Leave
Okay.
1 to go there. Now factor the bottom.
Then it will be t plus 1 and t minus 1.
Cross those out. Try to substitute again.
So then using, which problem are we on now? Okay, now I get 1.
7, yeah, 1.
I just put 1 in, so then that would be 3 over 2.
Yeah. Okay. 28, you're going to factor top and bottom. Do the same thing. 29. First of all, 29 is 0 over 0. Let's look at it. Let's try to do it. We got minus 2x minus 4 over x cubed plus 2x squared. So as x is going to minus 2. And we can see that it's 0 over 0. So what do we want to do next?
So then I'm just going to factor it.
Yeah, pretty much factor as much as you can. In other words, the secret to these problems, the last 15 problems we've done, has just been factoring. And that's usually the first thing they teach you. That's why I was surprised to see problem 22 on there, which is the hardest technique that they have, where you multiply top and bottom by the conjugate. So what are you going to do with the top? How do you factor out something from the numerator? Better yet, do the bottom first. It's the greatest common factor in the bottom.
Okay. So would it be x squared plus x, or like with the x on the other side?
When you factor out an x squared, which is the greatest common factor, what are you left with?
X plus 2.
All right. Which tells me that I want an x plus 2 in the numerator. How do I get an x plus 2 in the numerator?
X plus 2 and x minus 2.
No. What's the greatest common factor in the numerator?
2.
Minus 2.
Or minus 2, yes.
Notice that if I take a minus 2 out, I'm left with x plus 2. Redistribute that, you get that.
Oh. Okay, then you have negative 2 over x squared.
Yeah, and now resubstitute, so you get
4, or negative 2 over 4. So then I simplify and that'll be negative 1/2.
Correct.
Okay.
Okay.
The one thing I really wanted to go over is the last page that I sent you.
Okay.
There's some really long problems.
Quick here.
Okay.
Because the next problem is pretty much slightly different than the previous ones, but I'm sure you can figure it out. Where are we starting? At the top? Yeah, let's do that. That's a different looking one. In other words, we don't have that much time, and unfortunately I have a 4:30, so if we substitute, we get 0 over 0. If I turn that into the fraction that it is, you with me?
Yes.
Now this is the second technique, if I'm not mistaken. And this is where you have to actually add or subtract the fractions in either the numerator or the denominator. Well, combine those two, what do you get?
If I combine both of them?
Yeah, what's the common denominator going to be?
Would it have to be x?
Uh-huh. What's the new numerator going to be?
1.
1 minus x. Notice that 1 minus x over x is the same as what I have circled there.
Yes.
And that's what you always want to be doing in math, is when you're not trying to change it, make sure you didn't change it accidentally. Because all I did was I wanted to turn it into a single rational quotient. Now I'm dividing that by x minus 1. So let's look at what we have here. We have 1 over x. 1 minus x over x is our numerator. Our denominator is x minus 1. Now what can I do?
Factor out x.
No, we're done factoring. This is not a factoring problem.
Or substitute.
No, let's go ahead and execute the division. How do you divide when you have fractions?
Reciprocal multiply.
Yeah, so I'm going to multiply that by 1 over x minus 1. For some reason, people don't think of that very often when your denominator is not a fraction. But you can always assume there's a 1 under that.
Uh-huh.
Okay, so now when I multiply, something very interesting happens. Can I do anything with that 1 minus x compared to x minus 1? What is 1?
Crossing out.
Almost. 1 minus x over x minus 1 is always negative 1. In other words, A minus B divided by B minus A is always -1, no matter what the numbers are.
Oh, okay.
And remember that, because that'll be the trickiest problems you face, or ones like this, where you don't have, typically you're looking for identical things to cancel, right?
Mm-hmm.
These aren't identical. 1 minus x over x minus 1 is not identical, but it is equal to -1. So if I cross them out and replace them with, instead of a 1, a -1, now I'm left with -1 over x. And I know that's not going to 0 over 0. As x goes to 1, there's our answer.
Okay.
Okay. 32, same thing. The solution to 32 is to add the numerators together to form a single fraction. And then flip that and multiply, and you'll see magical things happen.
Okay. So I have to get a common denominator first.
Well, what's the common denominator for 32?
X plus 1 or x minus 1.
The product of those two. Whenever you
Okay.
have
So,
fractions
well,
with variables, the common denominator is almost always the product of this times that. And don't multiply them together. Leave them looking like this. X minus 1 times x plus 1, that's your common denominator. And then
okay.
on the top left, it's going to be x plus 1. And then I'm going to add to it the x minus 1. And you can see what's going to happen here. The 1's are going to disappear, and I'm left with 2x in the numerator. That's going to go away when I flip the bottom and multiply. Just remember, the bottom is x over 1. So when you flip it, it becomes 1 over x.
Okay.
Okay? So this is the second technique. There's basically only 3 that I know of. Now, there's factoring, number 1. There's adding together fractions and then simplifying, number 2. And finally, number 3, you would do on problems like 37. See the radical sign? Well, that's your flag that you need to multiply top and bottom by the conjugate of this complicated looking thing here. In other words, the square root of x plus 3 plus 2 is what you want to multiply the bottom by. That's the conjugate of that. On number 38, same thing. You want to use the conjugate. You want to multiply the top and bottom by the square root of x squared plus 8 plus 3. And always leave it, in other words, and the reason you do that is so you can simplify the top. And it does get rid of the radical sign.
Okay.
On 42, same thing. You got a radical sign. What's the conjugate of that? 5 plus that whole thing.
And then just put them together.
Yeah, once you multiply by the conjugate, you see very nice things happen. You end up with something that does not have a radical sign, at least not in the bottom. It doesn't. You're going to have a radical sign in the top, but you'll be able to handle that. It won't end up being 0 over 0.
Okay.
Taylor, I got to run. I got a 4:30.
Okay. Thank you. Have a good day.
You too. Talk to you next time.
Sounds good. Bye.